Hi, today we want to consider question 6C of the elective mathematics paper, that is July 2020 paper of the H6 examination. It says that we are to find the true set of 3x exponent 1 over 2 plus 5 minus 2x exponent negative 1 over 2 being equal to 0. So how do we solve for x in this equation? Now, for this particular equation, what we can do is we can try making sure that the x exponent 2 or x exponent 1 over 2, stand out. And that is what we are going to do. So for the first term, that is, we have 3x exponent 1 over 2 plus 5. The third term, that is the minus 2x exponent negative 1 over 2, we can rewrite that as minus 2 over x exponent 1 over 2, that is indices, is equal to 0. Now the x exponent 2, we can see it clearly in the first term and then the last term. So in that case, we can do some representation. So we let a variable of our choice, so let's say let y be equal to x exponent 1 over 2. Now in this case, wherever that we see x exponent 1 over 2, we substitute y there. So for the first term, we are going to have 3, we have our y because we have x exponent 1 over 2 here, plus 5 minus 2 over, once again, our y because we have 2 over x exponent 1 over 2, and that is what we are representing it by y. Now this is equal to 0. So we are having an equation here involving a variable y. So let's solve for the y. Okay, so we have 3y minus 5. So 3y plus 5 minus 2 over y is equal to 0. In this case, we have a fraction and the denominator is y. So we try finding LCM. So our LCM is going to be the y. We multiply through this equation, that is multiplying each term by the y. So we are going to have y multiplying the 3y plus y multiplying the 5 minus y multiplying the 2 over y is equal to the y multiplying the 0. And this side is going to give us 3y squared plus 5y. This y will cancel this y, and this side will give us minus 2 is equal to 0. Now we are having quadratic equation. So let's solve for y. So how do we solve quadratic equation? We take our constant, which is negative 2. We use that to multiply the coefficient of the y squared, and that will give us negative 6. We find factors in pairs for the negative 6, in which when we multiply we get negative 6, but when we add we get a coefficient of the middle term, and that is positive 5. So in this case, the perfect pair of factors that we can use will be 6 and negative 1, because when you multiply 6 and negative 1, that will give us negative 6, but when you add them, it's going to give us positive 5. So let's use that. Therefore we are going to have our 3y squared plus 6y minus y minus the last term minus 2 is equal to 0. We take the first two terms. What is the common factor there? The common factor is going to be 3y. So we have our 3y. We open our bracket. We are going to be left with y plus 2. We take the last two terms. The common factor there is going to be minus 1. We open the bracket. We are going to have y plus 2 is equal to 0. So in this case, we are going to have y plus 2 and then 3y minus 1 being equal to 0. So these are the linear factors for this quadratic expression, but it's an equation. So we are going to take each linear factor, then we equate that to 0. Okay. So we have y plus 2 and then 3y minus 1 is equal to 0. So we take each linear factor. So y plus 2 will be equal to 0, which implies that y is equal to negative 2. Okay. Now again, we take the other linear factor. That is 3y minus 1 is equal to 0. And we're going to have our 3y being equal to 1, which implies that when we divide both sides by 3, we are going to get y to be equal to 1 over 3. Therefore, we have y to be equal to negative 2 and then y to be equal to 1 over 3. But from the question, we are not solving for y. Y is not our main variable that we are solving. We are solving for x. But our y is equal to x exponent half. In that case, we are going to take the y values one by one, then we equate that to the x exponent half, because that is our y. Okay, so if y is equal to negative 2, then x exponent 1 over 2 will be equal to negative 2. Now from this equation, how do we solve for x? We are having x exponent 1 over 2 is equal to negative 4. If we want to solve for x, or if we want to make sure that x stands alone, then what we are going to do here, we have to square both sides. If we want to solve for x, then we need to square both sides. The reason is x exponent 1 over 2 is the same as square root of x, and that is equal to negative 2. So if you are solving for x, if you want to make sure that x stands alone, then we need to square both sides. So we are going to have the square root of x being equal to exponent 2, and then this side we are going to have the negative 2 all exponent 2. We are going to have our x to be equal to positive 4. So we take the other linear factor, or the other value for the y, that is y being equal to 1 over 3. Again, when y is equal to 1 over 3, then x exponent 1 over 2 is equal to 1 over 3. So the same thing, if we want to get rid of the exponent 1 over 2, we square both sides. So we are going to have our x exponent 1 over 2 all squared being equal to 1 over 3 all squared, so that this 2 can cancel this. It's the same as the square root, so please don't get confused. So we are going to have x exponent 1 being equal to 1 over 9. In this case, this exponent 2 affects the 1. The same exponent 2 affects the 3. Okay. So this will give us x being equal to 1 over 9. The question was asking us to find a true set. In that case, we have our true set to be equal to x such that x is equal to the first value, that is 4, and the 1 over 9, and that is our true set. This brings us to the end of this question. Okay, thank you for watching this video, but please don't forget to subscribe to the channel SoloAns TV. Once again, if you have any question, please feel free, just comment and we'll address that. Thanks for your time.